This session, we'll be learning about complex CPU scheduling algorithm questions which are asked in the previous GATE examination. So this question is based on shortest remaining time first. Shortest remaining time first, nothing but SJF with preemption. SJF with preemption. So what is the basic information is given? There are 5 processes and their execution times. Execution times are nothing but bars times only. Okay. So different processes have arrived at a different time units like this. Now let us execute. What is his intention? He is asking us to find average process turnaround time. Let us solve. And now at 0, there is only one process available by name A. A is executed because you need to be very careful as and when the question is asked on preemptive nature. So you're supposed to take care of execution times up to next arrival times. This is so important. In this case, what happened? A has got arrived, no other process is there along with A. So A is executed up to 3 because next process is coming exactly at 3. So the balance of this is this. And now A is passed. Now A is currently running, B is also added. Between this and between this, the B is shorter, so I'm passing B. Now your question is that how many units I should pass till the next arrival time. So next arrival time is 5. That too I need 2 units, so I can consume 2 units completely. After executing 2 units plus 2, then it becomes 5. So B is completely used 2 units, so B can be removed from the queue because it is completed. Now A is continuing. Exactly at 5, one more process is added, that is nothing but C. So among A and C, which is having the shorter, this need 4 and this need 3. So A will be given a chance till the next arrival time. Your next arrival time is exactly 7. So 2 units I have consumed of A, balance is 1. Now A is carry forwarding, C is also carry forwarding. Exactly at 7, D also arrived. So among these 3, which is the shorter bus time, A, C, D, among A, C, D, this is completely removed. Among A, C, D, the shorter one is A only. So A is completed after taking 1 unit of time. A got completed. Now C and D are there. Now there is again competition between C and D based on shortest remaining time first. So right now A got completed at 8 and B got completed at 5. Let us note down. Now between C and D, which is having the shorter? So C is having the shorter, so C is passed because C time is 4 and D time is 6. Execution time. So C is passed up to next arrival time. Next arrival time is 10. So it consumes 2 units, so 2 units are left alone. Now exactly at 10, C is carry forwarding, D is there, E is also joined. Among these 3, C, D, E, which is the shorter one? So which is the shorter one is C is the shorter one because it needs 2 only. So therefore C gets executed. Again C gets executed 2 units of time, then it becomes 12. So at 12 C also got completed. Now after that there are 2 more processes are there at 12, D and E. Among them which is shorter one, E is a shorter one. So E is executed completely 3 units because even you cut one, it is lesser as comparatively to process D. So D executed plus 3 units. So 15, it is also got completed. Only one process left alone, that is nothing but D. There is no race because only one process, there is no CPU scheduling also required. Take it for granted. Whenever ready queue has got only one process, you can execute it directly without having any process scheduling algorithm. So D is running quietly 6 units. By 21, D also got completed. That's it. So C completed at 12, A completed at 8, B completed at 5, And now let us identify turnaround time. Turnaround time is exit time minus entry time, that is CT minus CT, 8 minus 0, which is 8, 5 minus 3, which is 2, 12 minus 5, which is 12, 21 minus 7, which is 14, 15 minus 10, it is 5. So average turnaround time he asked, right? 8 plus 2, 10, 17, 17 plus 14, 31, 31 plus 5, 5, 36 by 5. So this is your answer, 36 by 5. So 36 by 5, altogether it is this one, 7.2. So let us talk about the second question. This is based on priority. Priority without preemption. So very nice. Without preemption, no preemptions needed. So let us talk about priority preemption, priority without preemption. So there are four processes P1, P2, P3, P4, 0, 1, 2, 3, burst times 5 to 6, 8. Priority is given. Highest number has got low priority according to this question. But in general, highest number gets highest priority only. But he mentioned very clearly 3 is highest in the sense lowest number get high priority. So these are having high priorities. That means one has got utmost high priority. But there is a clash. How to resolve that clash, I will explain now. Now you observe at time 0, there is only one process by name called P1. Whenever only one process available, you can continue execution. That too, this is based on priority nature. And he said very clearly, no preemptions needed. Without preemption, it's very easy to solve. So now you all get a doubt. I am sending P1 for the execution, but you may get a doubt that its priority is 3, it's low. But P1, P2 and P4 priorities is high. Why are you not sending P2 and P4? Because they have not arrived at that time. They have not arrived at that time because only one process is there in the ready queue. Therefore, it passes. When it passes, you can't preempt it because very clearly said that there are no preemptions applied. Therefore, P1 completely executed 5 units and by 5, it got completed. So P1 completion time is 5. During 0 to 5, other processes have come P2, P3, and P4. Now you cross verify which is having the highest priority. So this guy has highest priority and this guy is also having highest priority. Both are ones. Whenever priorities are same, we need to cross check lowest arrival times. If at all arrival times are also clash, then you need to look at the lowest process ID. But fortunately, here this guy and this guy arrival time P2 has come before P4. Now P2 is passed here and it requires how many units? 2 units. So P2 got completed by 7. You remove from the queue. So P1 is removed, P2 also removed. Now the rest of the process are there, P3 and P4. Now after removal this, among these two, which is having high priority? P4 has got high priority. It is executed 8 units of time. By 15, it got completed. And after that, only one process is left alone, that is P3. It is executed for how many units? P3 is executed for 6 units of time. So P3 got completed by 21. That's it. P1 completion time is 5, P2 completion time is 7, P4 completion time is 15, and P3 completion time is 21. So what is the question he asked? Average waiting time. Average waiting time. So turnaround time. Exit time minus entry time, which is 5 minus 0, 5, 7 minus 1, 6, 21 minus 2, 15 minus 3, 12. Waiting time is, what is the waiting time concept? Turnaround time minus your burst time. How much time you are working with the CPU. So turnaround time 5 minus 5, 5 minus 5, it is 0. And 6 minus 2, it is a 4. And 19 minus 3, 6, it is a 13. 12 minus 8, it is a 4. So just sum it. What is the sum of waiting time? 4 plus 13, 17 plus 4, 21 by how many process? 4. So 21 by 4 is your answer. 21 by 4 is your answer. So let us see very interesting question. Very typical question. This time you are having two CPUs, CPU 1 and CPU 2, along with IO time is also needed. It is a multiprocessor architecture. So how are we going to solve? And he asked very clearly that what are the finish times of the processors P1, P2 and P3? Finish time means CPU 1 time, IO time and CPU 2 time. Remember, every process has three times are given. CPU 1 time, IO time and CPU 2 time also. Now, here one important thing is that IO time is overlapped with the CPU time. So you can ignore them. Whenever CPU is busy because of multi-programming concept, IO can also do its tasks parallelly. You don't link this and IO time with the CPU time. So let me solve. So arrival times. Let us take a Gantt chart. And what is the scheduling algorithm we want to apply? That is also we need. The scheduling algorithm he asks us to apply. Scheduling algorithm is what? Preemptive priority. Yeah. Earlier it is without preemption. This time preemptive priority. He said that lowest number gets highest priority, like previous question only. So 1 get highest, 3 gets lowest. Now at 0 I am targeting. 0 there is only one process by name P1. And you please understand one important thing is that we are working with the priority with the preemptions concept. Please listen carefully this question. So 0, there is only one process and that too there are two CPUs. The first one is CPU 1 and second one is CPU 2 time. Okay, CPU 1 time and CPU 2 time. So two CPUs is supposed to execute. In middle IO is also there. IO time is overlapped with the CPU execution time because this Gantt chart we are preparing only for CPU only. This Gantt chart we are preparing only for CPU execution. So at 0, there is only one process by name P1. So P1 is entered. Forget about its priority because only one process is there at time 0. Whenever multiple processes are there, when we will cross check about priority. So how much time needed? 1 unit needed. So it execute 1 unit. Observe, it execute 1 unit. Then immediately it goes from CPU 1 to IO. Please observe carefully. It goes from CPU 1 to IO. So CPU 1 is idle. Now right now with IO, what is the process is there? P1 process is there. Now the second process may takes by CPU 1. And after IO P1 is completed, it goes for what? CPU 2 time also. That's the order. So P1 is executed for 1 unit of time and P1 went for IO. How many units? How many units? 5 units. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That is right. If at all it needs, we will increase the Gantt chart. So now, after executing 1 unit of time, CPU 1 completed. So it is taking how many units IO? 5 units IO. So 1 plus 5, it is 6. That means process 1 will come again exactly at 6. Total 5 units. 1, 2, 3, 4, 5. 5 units. 1 plus 5, it is nothing but 6. P1 will wake up. That means it come out from IO queue and seeking for CPU2 for access. So this is P1 IO. That is right. It is P1 IO. So during IO is busy with P1, CPU1 is idle. Therefore, immediately second process will go for it. But the second process has come at 2. P2 has come at 2. Only one process. P3 has come at 3. That means this 1 and 2 CPU is idle. This 1 and 2 time CPU is idle. Exactly 2 process 2 has come. So process 2 has come and executes how many units? Up to next arrival. Up to next arrival is what? 3. So exactly at 3, P3 is also there. That means only I could able to execute 1 unit, balance is 2. Now P2 also carry forwarding here. P2 also carry forwarding here. Now which process is sent right now? P2 is sent for 1 unit of time. Balance is with CPU1, 2 more units needed. Now let us go for, there is a tie between P2 and P3. Now you need to check out priority. So which process has highest priority? P3 has highest priority. So P3 is given how many units? All the units you can give CPU1 all the units because it has got the highest priority than anybody else. Therefore, you need not cut one by one. Simply you can make use of 2. So P3 uses how many units? 2 units. So P3 uses 2 slots. From there, P3 goes for IO. How many units IO you need? As P1 needed 5, you are asking for 3 units. So 3 units means this from here. From here, you're asking 2 units, 3 units. That means 1, 2, and 3. So P3 will wake up exactly here for CPU2 burst time. Okay. Now during this time, because P1 is wake up at 6, but 5 to 6 there is a slot empty. That slot I can give to P2 because P2 is still under waiting queue only. So P2 is executed 1 more unit of time. Balance is 1. Now P2 is carry forwarding, but yeah, one more process is also wake up at 6 P1. Now you cross verify which is having highest priority among P2 and P1. Among P2 and P1, which is having highest priority, P1 has highest priority because highest is here only 2 because P2 is mentioned as a lowest. So P1 is given a chance once again. How many units? Till P3 arrives because P3 has got highest more priority than anybody else. So we will execute P1 up to P3 wake up. So P1 is executed 2 units, balance is 1. Now it is working with the CPU2. Observe carefully. This is working with CPU2. Okay. Now P3 is wake up exactly this. P1 is there as well as P2 also there. Among these three, which is a shorter one, sorry, which is having a highest priority, P3 has got highest priority. So P3 is executed rest of 1 unit, and P3 will be removed from the queue. P3 is completed at what time? 9. Now there are 2 more processes fighting, P1 and P2. Among that, we want to check the priority, P1 and P2. P1 is only highest priority, therefore it executed the rest. So P1 is executed and it is completed at 10. So P2 is balanced. So P2 is executed. Still P2 need how many units? Only 1 unit only. So P2 is executed 1 unit and it goes for IO. It goes for IO. How many units? 3 units. So 1 and 2 and 3 units. This is the P2 IO. This is P2 IO. So P2 IO after completion, P2 again wake up and execute 1 more unit. Exactly P2 will be given a chance here and it completes that 1 unit also. Second CPU burst time. So it is completed at 15. That's it. So what is asked? Process completion times 10, 15, 9. So 10, 15, and 9. So this is one of the important point we will highlight from this example is IO time is overlapped with the CPU time. When IO is running, parallelly CPU also can make execution of other processes. Let us take one more question. This is based on longest remaining time first and round robin with 2. This is also called as RR2, which is having a lowest average turnaround time. Lowest average, that means you need to solve with LRTF. You also need to solve with the round robin. So 2 you need to solve. First, let me solve with LRTF. LRTF is nothing but preemption nature of LJF. Preemptive nature of LJF. So LJF with preemption. LRTF stands for longest remaining time first. Okay. So first let me execute LRTF at time 0. Only one process is there by name A. A got executed. How many times? Don't execute all the 3 times because preemption. When there is no preemption, then you can execute all the 3. Execute up to next arrival time. So I'm executing only 1 unit, balance is 2. So at 1, A is carry forwarding, B is also join. B is join. Among A and B, which is having the longest burst time, this guy. Execute up to next arrival. Next arrival time you execute. Next arrival time is what? 4. That means I can execute B how many times? Second, B how many times? Third, B how many times? 4. That means 3 times I have executed, balance is 3. Now, still A is not yet completed, B has not yet completed. Exactly at 4, C is also dropped. C is also arrived to ready queue. Now you cross verify among 2 and 3 and 4, which is having the longest time. C has got longest time. You execute C up to 1 unit. So I'm executing up to 1 unit. Why? You will come to know why I'm executing 1 unit. At 5, still A, B, C is there. Because D has come at 6, we don't consider D. Now among A, B, C, which is having the longest time? B and C are having longest time. Whenever burst times are same, then you need to consider lowest arrival time to break the ties. That is a default rule. For any kind of tie breaking, you're supposed to use lowest arrival time. So among B and C, I'm comparing because they are having highest burst time than A. Therefore, B has come earlier than C. So B has given a chance up to how many units? 1 unit. So B is reduced to 2. Here it becomes 6. A is carry forwarding, B is carry forwarding, C is carry forwarding. Now, exactly at 6, D also is arrived. So, which is having the longest time this time? This is needed 2, this is needed 2, this is needed 3, this is needed 2. So, C is executed 1 unit of time and balance is 2. Now, still A, B, C, D is carrying on. So every process has got 2 burst times only. Whenever burst times are same, then you need to consider lowest arrival time. So here lowest arrival time is A. A has given a chance, cut only 1, don't cut 2. Then it becomes 8. Still A, B, C, D is carry forwarding. This time 1, 2, 2 and 2. Which is having a longest burst time? 2 is the longest. But the 3 longest burst times are same. Then you consider lowest arrival time process, which is nothing but B. So B is executed 1 unit of time, balance is 1. Now still A, B, C, D is carry on. A, B, C, D is carrying. Now among C and D, which is having a longest burst time, both have 2. Then but break the ties using lowest arrival time. So C has come first. So C is executed 1 unit of time. And now A, B, C, D. So among 4, which is having a longest burst time because they need only 1, 1, 1. So 2. So it is reduced by 1. So D is executed at 11. So still A, B, C, D carry forwarding. Every process need left alone only 1, 1 burst time. Whenever burst times are same, then check it. this time A will be repeated, this becomes 0, then B will be taken over, it becomes 0, then C will be taken over, it becomes 0, D also will be taken over, it becomes 0. That's it. So this is 12, this is 13, this is 14, this is 15. So let us write the completion times. Completion time of A 12, completion time of B 13, 14, 15. Turnaround time CT minus AT. What is CT? 12 minus AT, it is 12. 13 minus 1, it is 12. 14 minus 4, it is 10. 15 minus 6, it is 9. So waiting time is nothing but turnaround time minus your burst time. So turnaround time 12 minus 3, it is 9. 12 minus 6, it is 6. 10 minus 4, 10 minus 4, it is 6. 9 minus 2, it is 7. That's it. Now he is asking average waiting time. Average waiting time is nothing but 9 plus 6 plus 6 plus 7, which is 12, plus 9, 21, 28 by 4, which is roughly 7. Okay, now let us see RR2. RR2 means round robin 2. Round robin 2. So you need to concentrate ready queue. Whenever you talk about round robin, you need to take a ready queue. At 0, who has come? A has come. At 0, A has come. So RR2 means round robin time slices 2 units. That is the meaning. So A is executed 2 units of time, balance is 1. During 2 units of time, who also added into the ready queue? Only B is added into the ready queue because it has arrived at time 1. So A is not completed because still it need 1. So A will be added into the queue. According to the ready queue, B will be pulled to CPU. B is also can execute max of 2, so balance is 4. So B is executed. So during 4, one more process is also added by name C. B is not completed, so B will join to the queue. So this time in the queue order, A is there. A executed balance 1. Actually, I got to execute 2 units, but I don't need. I need only 1. At 5, A got completed, so remove from the queue. Its completion time is 5. Okay, so A can be removed. A need not add into the ready queue because it's completed. So in the ready queue, C is there. So drop the C. C need 2 more units. So balance is 2. C is executed till 7. Then C is not completed, right? So during execution of C between 5 and 7, one more process is also added by name D. Yes. So C will be tailed back of D. Now in the queue, B is there. So B got executed. How many? 2 units. So 2 is balanced. By 9, it got completed. B is not completed. It joined to the queue. And next in the ready queue order, D is there. So D will be sent. It is executing exactly 2 units only. It got completed. So D can be removed from the queue. In the queue order, C is there. So C also executed 2 units. It becomes 0. Then after that, one more process is left alone, that is a B. So B also executed 2 more units. 15, it got completed. So B completed at 15, C completed at 13, D completed at 11. So turnaround time, what is the turnaround time? CT minus 80, it is a 5. 15 minus 1, it is a 14. 13 minus 4, it is a 9. 11 minus 6, it is a 5. Waiting time, turnaround time minus burst time. 5 minus 3, 2. 14 minus 6, 8. 9 minus 4, 5. 5 minus 2, 3. It is 18 by 4. This is having a lowest waiting time. Therefore, round robin is answer. So this is another interesting question. Very, very important and interesting question. This is based on Preemptive priority scheduling algorithm. Preemptive priority scheduling algorithm. And PID, this is CPU burst time. This is IO burst time. Okay. And ABC are started at what times? 0, 50, 100. So their arrival times are 0, 50, and 100. Their arrival times. So what he is asking? Process B completes its first IO operation. Process B completes its first IO operation. So let us work on it. So arrival time 0, 50, 100. At 0, no other process is there except A. This is a priority with preemption. Priority with preemption. Priority with preemption. So preemption means you need to execute up to next arrival times only. Clear? Now let us say A is executed how many times? Up to next arrival time. Next arrival time process B is coming. So A is executed up to that. Balance of CPU after executing 50 units are balanced. Now A is continue. Among EAB, which is having a highest priority, he said that highest number is low. That means lowest number is high. That means this guy is having a highest 2. This guy is having highest 1 because 4 is a lower number. He said that 10 is a higher number, that is considering as low. Actually, highest number always highest priority. This time he is asking in inversion fashion. Among EAB, which is having highest priority, among this and this, which is having highest priority, H2, that is nothing but B. So B is passed till next arrival time. Next arrival time of the process is nothing but 100. C is joined. So B is given only 50. So 300 is left alone. Now still ABC is continuing. Among ABC, which is having highest priority, 4, that is nothing but PID C. So C will be executed how many units of time? You can continuously give because that is only highest than anybody else forever. Therefore, you can cut 50-50 or you can take it completely 200 units. So I am taking 200 units from process C. From process C, how many units? 200 units, which is nothing but 300. It got completed. Okay. Now it went into IO. Exactly. P1 IO started. How many? 500. 300 plus 500. Somewhere it is rising at 800. Again, it is rising at 800. Okay. Now continue. Here, C is left over because A and B are continuing. C already went to IO. The red color mark which I mentioned, this is a C IO time. Here to here. Then after that, among AB, which is having highest priority, among AB, B has got highest priority. So therefore, B is given how many units time? As many times you compare among A and B, B always higher. So B takes complete 300 units. B take complete 300 units. So B is executing till how much time? 600. B is completely executed how much time? 600. Somewhere here I will write 400, 500, 600. So B is executed completely 300. So now B is going to enter into its IO 500 units. Exactly 600 plus 500, 1100. Exactly at 1100, B IO completed. Exactly 800, C IO completed. Okay. Now, what is the leftover process? Because B also already completed its CPU and it is entered to IO. C also completed its CPU, it entered into IO. Only one process left, that is what? A. A is executed. How many I need balance? Only 50 only. So 650. A got completed. Now A will go for IO 5 more 100. So this time A is also needed IO time 650 plus 500. Exactly at 1150 A IO got completed. So that is your answer. What is your answer? B completes its first IO. B completes its first IO at 1100. This is B IO. This is A IO. So your answer is 1100. Let us see next question. SRTF, shortest remaining time first, which is based on preemptive SJF. So, but here very important, CPU 1, CPU 2. Two CPUs are given, one IO is given. And what is asking? Completion time of P3. Completion time of P3 means it has to execute CPU 1 burst time and CPU 1 IO and CPU 2 burst time. All three it should complete. That time we want to complete, find out. Let's see it. This is CPU 1, this is CPU 2, and we are working on SRTF, which is nothing but shortest job first and the preemptive nature. Okay. At 0, please see, at 0, two processes have come, P1 and P2. Among them, which is a shorter? First CPU, you find out. First CPU 1. Among them, which is a shorter? P2 is shorter. P2 is executed till, let me execute one unit. That is better always. I will execute one unit. So balance is 1. Now still P1 and P2, no other process has come. Among P1 and P2, which is having a shorter? P2 only. So this is executed P2. Now P2 begin IO 4 units. P2 4 units. 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now P2 go for IO because it's completed this. 2 plus 4, it is 6. Exactly. P2 will wake up again at 6. As I told you, IO time can be overlapped with the CPU time. So right now we are at 2. P1 is continuing because P2 already went into IO. At 2, one more process is joined by name 3. Among P1 and P3, which is a shorter burst time, among P1 and P3, P1 needs 3 and P3 needs 1. Therefore, P3 will be given a chance. So P3 is executed. How many units? Only one only it needed. P3 is executed and P3 also went for IO. How many units? 4 units. So 4 units. P3 IO, how many units? 3 units only. So 3 units, 1, 2, 3. Exactly. P2. This is P3. P3 also wake up at 6. Okay. Because it is needed 3 units. Right now it is 3, 1 unit and 2 unit and 3 units. That's it. P2 already into IO, P3 already into IO. This is P3 IO. Now the continuing process is P1. Still it is continuing. Now exactly time 3 because P4 has come at 5, so I can give chance to P1. P1 is executed twice. P1 is executed 1 unit and 1 unit, balance is 1. Exactly at 5, P1 is there as well as P4 also has come. P4 also has come. And there is no other process exactly at 5. So P1 and P4 among which is a shorter? P1 and P4. This needs 2, this needs only 1. So P1 will be given a chance. It becomes 0. Now here P1 will go for IO how many units? 2 units. The P1 IO 2 units. This is P1 IO. Now you see The continuing process are P4 is continuing now, but unfortunately P2 is the wake up, P3 is also wake up. Among these three, which is the shorter? One important thing I would like to say. What is that? P2 needs a second burst time, P3 needs a second burst time, but P4 needs still first burst time. Remember that, because P4 is not yet completed, but P2 and P3 is requesting for this and this. So you need to compare with CPU2 with CPU1. Now, which is having the shorter among 1, 2 and 2? So P2 has the shorter one. So P2 will be given a chance. That's it. P2 got completed by 7. It executed CPU1 IO as well as CPU2. Now, exactly at 7, P2 is not there, P4 is there, and P3 is there. Among P4 and P3, among P4 and P3, which is a shorter, this guy and this guy. Whenever both are having the same burst time, whenever burst times are same, then you need to look at who has come first. Who has come first? P3 only come first because he has come at 5. So P3 is given a chance now. How many units? Let us execute only one unit because other process is also there. That's it. And now exactly 8, P1 is there, P4 is there, P3 is also there. So P1 needs second burst time, that is 2, and P3 needs balance of second burst time. P4 needs first burst time 2. So which is a shorter? P3 is a shorter. So P3 is executed once again. It removed from the queue. It got completed by 9. It got completed by 9. So the rest of the queue is P1 and P4. So this is needed to, this is needed to. Again, burst times are same. You need to consider lowest arrival time. So P1 is win the race. P1 is executed 2 units because that is only shorter. Because even I cut 1, this becomes 1, 1 and 2. P1 is only shorter. So P1 is given 2 units. P1 got completed by 11. And only leftover process, that is P4. P4 is executed 2 units of time, then remove. Then P4 went for IO. P4 will wake up exactly 15. This is a P4 IO, exactly 15. During this time, no other process is there. Therefore, CPU is idle. This is a CPU idle time. Sometime you also ask CPU idle time. Here, CPU idle time is 2. Then after that, it wake up and it executes how many? Rest of the 1 unit of CPU2. So P4 got completed at 16. He asked about which process? P3. P3 completion time is a still time 2. CPU is idle. At time 2, two processes have come by name P4 and P7. So as there are multiple processes and that too they have come at the same time, and these ties can be broken generally with lowest process ID, but explicitly he said use the shortest burst time. So P4 will be pushed. So P4 is executed 1 unit of its time and 3 P4 got completed. So P4 completion time is 3. Now still P7 is continuing. No other process has come. So therefore P7 is pushed to next time. P7 needs 2 more units. So 3 plus 2, it is a 5. So P7 got completed at 5. Now duration 0 to 5, that means 3 and 5, 3 to 5. Who other process have come? P2 has come, P5 has come. So P2 and P5, because other process have come at different arrival times. Let us cross check. P4 is completed, P7 is completed, and exactly duration 0 to 5, there are other process have come, that is this Y, P5, and this process and any other. This process has come at 6, this process come at 7, this process come at 8. So there are two processes by name P2 and P5. So now who have come earlier? P5 come earlier. There is no tie. Directly you can take a P5 process. It is executed 3 units of time. Remove it. And P2 is there. Exactly 8. All other processes have come. Let us drop. P1 also come at 8. P3 also come at 8. And P6 has come at 6. Among these three, which have come earlier, P2 has come at, I'm circling, observe, P2 has come at 5, P1 has come at 8, and P3 has come at 7, and P6 has come at 6. So which has come first? P2 has come first. So P2 has dropped, and P2 executed 5 units of time. So 8 plus 5, it is 13, and P1, P3, and P6. Among P1, P3, P6, P1, P3, and P6. So P6 has come earlier. So P6, it is executed 1 unit of time, 14, and P1 and P3. Among them, P3 has come first because it has arrived at 7. P1 has come at 8. So P3 is executed 2 units of time, 16. Then only one process left, that is P1, which is executed 6 units, not 6 units, 4 units. P3 needs how many units? P3 needs 2 units, okay. And P1 needs how many units? 4 units. So 16 plus 4, it is 20. So what are completion times? What is asking exactly? Completion time of process P6. Process P6 has completed at 14. So that is only your answer. P1 is completed at 20, and P3 is completed at 16, P2 completed at 13, P5 at 8, P7 at 5, P4 at 3. Yeah, this is a very interesting question, and I've never seen this kind of question once again in any kind of exam. It's a very tough one. So there are different cases we need to analyze carefully. 3 tasks, T1, T2, T3. They are coming repeatedly for every 3, for every 7, for every 20 periodical intervals. And the priority of each task is inverse of its period. Inverse of its period, which is nothing but inverse of the priority of each task is the inverse of its period, which is 1 by 3, 1 by 7, and 1 by 20. And the available tasks are scheduled in order of priority. So it is using priority scheduling. And highest number gets highest priority. Each instance of T1, T2, T3, every time it is executed 1 to 4 milliseconds. And given all the tasks initially, they are coming at 1 millisecond, and preemptions are allowed. What is needed? T3 first phase completion time. T3 first phase completion time. Let us do. So PID 1, 2, 3, all have come at arrival time 1. Bus times are 1 to 4. And their period of arrival times for the next visit, for every 3 periodical intervals it is coming, and it is coming, and this is coming at 20. So when are they coming? Let us post. All have come at 1. So T1 is here, T2 also here, T3 also here, and they are coming at repeatedly different times. So it is coming next 3, 1 plus 3, 1 plus 3, 1 plus 3, it is 4. So T1 is coming here. And then after that 1 plus 7, 8. T2 is coming here. Then 1 plus 20, 21. T3 coming once again back. So this is how it is coming. First they have come at 1, and again T1 has come at 1. T1 will come again at 1 plus 3, it is a 4. Again T1 has come 4 plus 3, it is a 7. 4 plus 3, it is a what? 7. Again the same story, T1 has come at 1, T2 will come at 1 plus 7, 8, T2 will come at again at 15. That's it. Let us execute. Among T1, T2 and T3, which is having highest priority, highest number gets highest priority, it is been set. So T1 executed, I am executing with the red. This is idle, CPU is idle during this time. So T1 is removed and a queue consists T2 and T3. There is a race between T2 and T3. T2 and T3 which is having next highest priority, T2. So T1 only needs 1 unit, but T2 needs 2 units. So T2 is executing 2 units, 1 unit here, 1 unit here, and T2 will disappear. It will come again after this, after T1. That is exactly T2. That is the order I have written here. So T3, if you want me to write, I will write. T3 is coming at 1. Again, it will come at 21. Then after that, 41. Every 20 units it is coming. Now, T2 completed. Here also T2 carry on. So T2 remove. Now T3 is joined. Unfortunately, T1 is also wake up because T1 and T3, again T1 has got a good priority. So T1 is executed here. Next time also 1 unit only. So T1 cleared from this. Now these 2 slots, nobody is there, but T3 is carry forwarding. So T3 will be executed. Total 4 it need. T3 is given 2 units right now. 2 is balanced. Now T3 is continuing here. T1 is also wake up. But now T1 and T3 which is having highest priority, T1 only. So T1 will be needed 1 unit. So T1 is removed from this. T3 is continuing. Unfortunately, T2 also wake up. T2 needs 2 units. So T2 is carry forwarding here. Now T2 is executed. That's it. Again T2 will come at 15. T1 will come at one more time. 1, 4, 7 and 7 plus 3. It is coming at 10. Again T1 will come at 10. So this time T2 after executing we will remove. So T3 is carry forward. Again T1 and T3. Again T1 will be executed how many? 1 units of time. So remove T1. Next slot will be given dedicatedly to T3. How many units needed? 2 units. So T3 and T3. So T3 got completed exactly at 13. That is your answer. So very interesting question. So different case studies. One is arrival times all have come at same and they are revisiting every time at 3, at 7 and at 20. You need to add plus 3 and plus 7 plus 20 every time. Then their priorities are their periods only, inversion of their periods. That's a 1 by 3, 1 by 7, 1 by 20. So this is how to execute it. He asked up to here only. If it is continuing, you can continue. If at all few more units required, you can continue, but you can stop here because it is asked only for what? T3 first phase of completion. T3 first phase of completion is at 13.